let's look at this question. So suggest the cleavage patterns that can be seen in 2-methyl heptanol. So heptanol is like 1, 2, 3, 4, 5, 6, 7, right? So 2-methyl CH3, 3, 4, 5, 6, so CH3. So dimethyl heptanol. So we have this to be CH2OH, right? This one is hydrogen, 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 and CH3, right? So basically this one is 1 degree carbon. This one is 1, 2, 3. So this is 3 degree, 1 degree carbon, 2 degree, 2 degree, 2 degree, 2 degree. Sorry, this is 3 degree as well. So this is 1 degree carbon. This is the carbon attached to the functional group. This is 1 degree carbon. So basically, the fragmentation would we can have different fragmentation pattern. The OH group can leave. That is one. The OH group. So suggest the cleavage pattern. One cleavage pattern is that this OH group leaves, and we are left with the O structure. The O structure, right, minus OH. So let's see, the O structure here is this. That will be plus OH dot, right? So that is the first one that we can have. So we can also have fragmentation here. We can have fragmentation any point there. But let's find the most stable fragmentation pattern. So the most stable fragmentation should be between 2 and 3. So fragmentation can happen here. Fragmentation can happen here. So let's say fragmentation happens here. This smaller part will go as the radical, and then this other part will go as the positive. Let's say we have the fragmentation here 2 and 3. This part might go, this part, any of the two parts can go as the positive and negative, but it's important to include the functional group in that part. So this will most likely be the most stable product. Like this will most likely be the most reasonable cleavage point. Like we can have fragmentation at different points to give the cleavage, and if you have to answer this question, suggest the cleavage pattern that can be seen. So you can write the whole structure plus this. That's the first. When you cut here, you can even do for this, and then you write the cation and the radical. You can cleave here, and then you write the whole stuff there. But I just want to like point out the most stable one. So the most stable one should be when you fragment here, right? So this part will go as the radical, and this whole part will go as the cation. Like we're going to have CH3, CH3, and this one is hydrogen, right? So this will be radical plus CH2, 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 CH3, hydrogen, CH2, OH, right? This will go as the cation. We can also have when this one will be positive and this one will be negative, right? But let's look at this other point. When we fragment here, right? This is 2, 3 also. When we fragment here, okay, this one will go as positive. Oh, this should be the most stable one. When we fragment here, actually, we are going to have something like CH3, CH3, hydrogen, CH2, CH2, CH2. This one will be dot plus this one CH3, because the product here, the carbocation here is secondary, but the carbocation here is just primary. So this one will be CH3, CH2, OH. So this should be the most stable. This should be the most stable fragmentation pattern there. So let's look at this. So just the cleavage pattern for phenylbutane. So let's write it out here. So 2, phenylbutane is this structure, right? And then butane, 1 CH2 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 CH3, right? So basically fragmentation can occur here, can occur here, can occur here, or any point, though it will less occur here due to it will most likely not want to occur here, but it can also occur there. As when we fragment here, we are going to have this plus this one. We're going to have this. So, but let's look at it. Let's solve it out. So the first fragmentation, if you cut here, we're going to be left with this structure, right? This one, CH2, 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 and then we have plus CH3 radical. So that's like the first. We can also cut here. So that will be B. Let's put it there. That will be this. So if you are told to identify the fragmentation pattern, you can do this. So plus CH2, CH3, right? So that is dot here. So we can also have C when we fragment here. So that will be let's write the C here. So that will be this Bayesian ring rather. So we have CH2, right? So there will be plus here, and this one will be CH2, CH2, CH3, right? This radical. But this one can further become this. This one will further, you have to note that you must be able to discern that this one will further become further become a 7 carbon ring, right? So we have this. So it will therefore now become a 5 carbon when it loses like the way we've explained here. The way we explained, let's try to bring it out. Let's try to bring it out. At this point where we explain, yeah, it becomes this, right? It becomes this ring. So when we expel this one, it becomes 7 membered, and then you expel C2H2, then you have this structure there. So let's go back to what we had initially. So so this is going to become this, right? So that's the end of this. So we can also have, let's say D. D is when we fragment here, and we're going to have this structure, right? This is the ring plus, and then the all other one CH2 blah blah blah, now radical. So this one can also lose C2H2. Then you have this is C6H5, right? So when it loses C2H2, we are going to have C4H3 plus. So just take note of that. That's the answer there. So these are fragmentation patterns. So this third question, okay, we'll do a separate video for that one. Let's see. So on reacting the compound below with acetic anhydride and pyridine, it gives a compound 2. So when you react this with acetic anhydride, basically this OH here is replaced with acetic anhydride. It gives a compound 2, which on further reaction, like basically this is the compound here, react it with acetic anhydride, CH3, CO, CH3, I hope I'm right, with the, CH3, CH2, CO, CH3, right? When you react this with this, so this is going to, let me confirm the structure. Yeah, when you react this with this, it knocks out this hydrogen, right? And it's replaced with this. So this point you are going to have CH3, CH2. This part is like it's like yeah, we're going to have C double bond O, right, joint to this one, joint to this. So the next step is this. it gave compound 2. Let's say this is a compound 2 when this hydrogen is out already. So which on further reaction with hydrogen, with 1 mole of hydrogen, when you react with 1 mole of hydrogen in the presence of catalyst, gave compound 3. So 1 mole of hydrogen will give you we take away this double bond here, so we are going to have a single bond there, and hydrogen, right? So the structure, so the spectral change basically is just we are going to like do the fragmentation patterns for the structure. That's basically what we're going to do. We're going to do the fragmentation pattern. But let's stop here. Yeah.